warmer, I've taught in warmer classrooms out there. So actually, as a young child, when I say young child, the school that I went to up in Minnesota didn't have heat. I mean, didn't have air conditioning. It had heat, obviously. Like, you know, if you know anything about the United States, Minnesota's up in the north central part, and it's as cold there as it is anywhere else in the U.S., except for maybe Alaska. And sometimes it's colder than Alaska, but they don't have air conditioning. And in the spring and summertime, sometimes they'll get up to 35, 40, 42, 43 degrees without air conditioning. Doesn't happen often, but it does happen. Negative 40 is more common. Okay, let me jump in here and talk about the practice tests right here. That's the only thing I'm going to talk about today, and I'm not going to give you all the answers. I will post most of the answers on Facebook after I'm done here. So, but okay, this actually comes from the B test with some changes from last semester. So this practice exam does look exactly like the final exam with some change. I mean, it's not the exact same questions, but it's the exact format, and probably 70% of the questions are the same. So this is probably as good a review as you can get. So mention and explain. I hate using the word mention and explain, but because they are, Malaysia follows this thing called I can't even remember, Bloom's taxonomy or whatever, where you have to word certain questions a certain way. In other words, I would just simply say, define what are the following types of motors and give their characteristics right there. So, and versus going through and trying to read each one of these right here, I have the solution and this may not be all of them right there, but the servo is one that uses electronics to set a certain angle, typically between 0 and 180 degrees, normally used for small right there. So separate motors are used and again, I'm going to post this file right here. So don't try to write, follow that there. Separate motors and then of course and then the last one I had in here is DC motor, commonly used for robotic control. It does have feedback, but position sensors can be used to provide the position. Normally you would use this with PWM in order for speed control right there. I don't mention that right there. Okay, the joints, I list 4 joints right here, and I don't know if that's the same 4 joints that are on the test right there. Mention the various types of mechanical joints there. So I list 4 of them here. There are more. That's there. And again, a twisted joint that is also rotational. There's parallel, a revolving around it. And basically, these are from the first couple of lectures. So a lot of these questions come from the first lecture or two, and those slides are up there. So that's it. Okay. This is from a different question right here, but the answer is still the same. This is an open-ended question. In other words, the question that I had was, discuss the various issues that must be dealt with before self-driving cars could be permitted on the road in Malaysia. So also in your discussion, talk about, So this is an essay question. There's no right or wrong, single right or wrong answer for this one here. But when you talk about the issues that need to be dealt with before self-driving cars, the number one issue before you can put self-driving cars on the road in Malaysia is that you have to train those that are driving cars to follow the driving laws and rules. Because self-driving cars are going to expect people to stop at red lights and go on green lights right there. They're going to expect people to go down the correct side of the road. I don't know how many people drive Jalan Gambak. I ride a motorcycle on there pretty much every day, or a little scooter. I shouldn't call it a motorcycle. people who drive real motorcycles would yell at me for calling my Vespa a motorcycle. That there, and people, of course, in the States would call those of you that drive 150s and 200 small motorcycles as driving toys. So it's all relative right there. But regardless, I see lots of people going the wrong way along John Gombach on their little motorcycles and scooters and that type of stuff that there. So again, basically, one thing that would have to happen is that driving laws would have to be enforced and followed along with parking rules right there. I mean, I live down a street where each car was originally built 20 some years ago with one parking place inside the driveway. Now the average home has 3 or 4 cars, so they've widened the driveway, which is what my wife and I did, so we could fit 2 cars in. But then they also park 2 more cars on the outside, either parallel versus perpendicular, perpendicular versus parallel, or they double park. I mean, parking is a crazy thing in many neighborhoods right there. So again, one of the things is that, cars are expected to drive in their lanes and follow parking rules and that there. So that's, one of the things that has to be dealt with that there. So, and then when we get into the whole concept of replacing workers that there, and this is a huge one, and I'm not telling you how to write this, but you have to address the fact that these jobs need to be replaced with something else. And that's already a problem in developed countries like the U.S. I have friends of mine that worked in factories making good money back when the day was good. One friend of mine I went to high school with he opted not to keep his skill level up. Right there, he finished high school, got a job in a factory, life was good. He lost that job, he found another factory job, and then finally he reached the point there are no more factory jobs. He's my age, 60, right there. The retirement age in the U.S. is 65. Early retirement is 62. So he's several years away from retirement. And he's cleaning toilets like a cleaning lady at a public school. At 60 years old, and he's making minimum wage right there. So it's one of those cases where taxi driving has been a very lucrative career field for people for years, and it may go away. Right there. Uber is out on the road with driverless cars in cities in the United States, Europe, Australia. I mean, they're experimenting with them. They haven't found their way into Malaysia yet, but I guarantee they will at some point. So, and in your discussion, you might also want to mention that other occupations have disappeared with technology. This is not the first one. I remember back when I could pick up a telephone and dial 411, and an operator would come up and I would ask her for Joe Smith's phone number on Elm Street in Kalamazoo, Michigan. And she would look it up and tell me what the phone number is. Directory assistance hasn't existed for at least a decade or two. Those people are long gone right there. I remember going to a travel agent and saying that I want to buy 2 plane tickets round trip from Fort Wayne, Indiana to Kuala Lumpur, flying on such a date, and the travel agent would do her research on her system and come back and call me 2 or 3 hours later and say that'll be $600 per ticket or whatever, and your departure times that person's no longer in business right there. I remember even as short ago as 3 or 4 years ago, there was a lot of travel agents in Malaysia. Matter of fact, I remember 3 months ago there was one over at PV12 right across the street from me, next to my den. I don't know if anybody knows where that is, but there down Alcota in that area there. But there was a travel agent there that you could buy plane tickets. I was there 3 days ago, and that person's gone. So I'm talking about in the last month, this travel agent has now disappeared. So travel agents are disappearing. So when you look at my discussion about taxi drivers disappearing, this has happened in many occupations right there. So a friend of mine used to, take ticket reservations for United Airlines. At first her job got transferred to India, then the job got killed altogether, and because nobody buys plane tickets through a travel agent, through a person. They go through the automated menu, or they go online, right there. But again, so what's going to replace these jobs? That's a huge question right there. The United States is talking now about what they call a basic living wage that everybody would get whether they work or don't work, simply because there's not enough jobs left. There are not jobs. Donald Trump's going to bring them back, though. That's there. Yeah. So if you believe Donald Trump, all the jobs are going to magically reappear. That's there. Because he says that they all went to China and Singapore and Malaysia. That's where all the jobs went to. He's totally ignored the fact that automation has eliminated 80% of the job losses in developing countries, and it's moving into that there. Today's paper, Seagate, they're citing economic reasons, but in reality, it's automation. That they're closing a factory in China and letting 20,000 workers go or something like that, a huge number of workers go. It might be 2,000, I don't remember. I read the paper this morning. But again, you have to deal with the fact that there's going to be some displaced occupations. There's going to be new occupations that there. So one of the reasons everybody's sitting in this classroom is because there aren't the factory jobs that Malaysian students graduate for, and you go to work for a company in a factory building, When I was here 20 years ago, actually furniture was a huge commodity. We had a lot of furniture there. Shortly before that, there was a lot of garment companies. A lot of shirts and shoes and clothing was made in Malaysia. Those factories are all gone. You don't find, Nike has closed their Malaysian plant. They moved it to Indonesia where the workers are cheaper. So, so you've got to look at the fact that it's not all gloom because those jobs are replaced. And some of those jobs people don't want to do. Okay, question 2. Explain how the position of a standard servo motor is set by the computer. It is set by sending a particular repetitive pulse of a given pulse width, right there. So a standard servo will only go between 0 and 180 degrees, and there's a table right there. Some of you put it on the midterm practice set there. On the solution, I don't expect you to memorize right there, but again, it's setting a PW normally around 5 kilohertz. That's there. So in order to change the position, all you do is just change the duty cycle right there. Is what I put down as the standard answer right there. The speed of a continuous servo is done the same way right there. So when we send a pulse width to a standard servo, standard servos are designed to go to a position and stay there. A continuous servo is designed to rotate in both directions at various speeds depending on the pulse width. So to change the speed and the direction, you just simply change the pulse width right there. Again, the pulse width is right around 5 kilohertz is the signal that they're. Explain and show the wiring diagram that they're using on H-bridge. I think in my particular one, I just simply show an H-bridge part component right there. The right answer would be one that would look more like this right here, where here's your motor, and maybe I might be able to drop this. Boy, it is getting warm in here, isn't it now? Or is it just because I'm talking I'm getting warm? You guys might be cool, right? Okay. Right there. Okay, here's our motor. Right there. Our H bridge, I'm just going to show these as little boxes right here. And I'm just going to call them S1, S2, S3, S4. Now, they would be J-FETs in the normal drawing, but for sake of the final exam, it could just fit there. So to go to one direction, S1 is turned on and S2 is turned on. To go in the other direction, S3 is turned on and S right there. So we just simply turn on two of the switches to control the direction of the motor right there. And typically, this is shown here as we've got this is actually a dual right here, and we've got our 5-volt here. We've got our logic pin 1, our terminal pins right there. There should be a terminal 1 and a terminal 2. Where's the other terminal? Oh, heat sink and ground right there. Right here. And this just basically right there. So actually this one here is a dual, but it actually only has one enable line right there. So right there. So again, that there. And most of you had that right on the practice test right there. So explain the difference between open loop and closed loop. Discuss the different types of closed loop control. Again, open loop means there's no feedback right there. We just simply tell the motor to go a certain speed, and we don't measure the speed that there, and we hope that it's the right speed. That there. Closed loop, you can have closed temperature. That there where you measure the temperature, readjust the thermostat. We can, for example, speed control on a car. We can measure the speed of the vehicle and control the amount of petrol that goes through the carburetor, or actually it's not a carburetor anymore, it's the fuel injectors right there. You can tell I'm getting old when I still refer to carburetors that there. So again, right there. Position, range, velocity, and proximity, those are all fairly straightforward. Position just simply tells you what the position of a robotic arm. The range actually measures distance right there. In other words, if I've got an electric car, it would measure the distance between the front of the car and the back of the car in front of it right there, or the wall. Those usually use some type of ultrasonic beam. They could use light that there. Velocity is measuring the speed of something right there. How fast is my vehicle moving? How fast my arm is? Proximity is just telling me whether I'm close right there. And most of you have proximity sensors if you have cars. I know that when it reverses, that beep, 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 that's a proximity sensor that there. So you just simply know what those 4 sensors are. Explain how you can control the motor of a self-driving car. Assume you have 2 use DC motors. Those, again, if you're using DC motors, you're going to be using PWM as your speed control right there. And to turn left, you would slow down the left motor and speed up the right motor right there. To turn right, you would slow down the right motor and speed up the left motor right there. Assume you're following a track right there. You would have some type of optical sensor to see whether or not you go off the track. If you go off the track right there and you need to turn right, you just simply adjust the motors right there. So again, I'm not going to write that answer that. Question 4 is where there. Again, design a PLC lodger with a press, the following right there. you have a start and a stop, and this is a very basic question right there. Right there. And all we're doing on this particular one is we have, here's our start button right there. Here's our motor right there. You put the appropriate that there, and then we put our motor in parallel with it right there. And there's our start, and then we also put our stop button right there. There's our stop button right there. So again, that's there, and again, let me look at the, right there, design. Oh. Oh, I don't know. Again, I don't know whether these are the same right there. Yep, right here we go. That's what it should look like right there. And I don't know if these answers are the same right there, because the questions might be a little different. You know, I'm just right there. In which case, you got a different set of questions to look at. Right there. Okay, the next one right there is we look at that there. Modify that to light a red light whenever the motor is not running. That's just simply adding this line right here. Right there, that particular right there. The motor, if it's not running, turns on the red light. That's all we've done to that particular one right there. So it's just simply adding that particular one right there. Modify, explain what's meant by an anti-tie down. I really didn't discuss this in class. This is one that you want at there. What an anti-tie down circuit is that if you've got a machine press, for example, right there, where somebody is making tires, we'll just use tires as an example, right there, and they have to press, and this thing is vertical, and if your hand is in the press, pulling in or taking out tires, it's going to take your hand off, right there. I mean, literally, this thing's, you know, since it's making tires, it's probably sitting there at about 200-300 degrees Celsius in order to melt the tires and make that there. It's also pressing the rubber into the tires right there. And this doesn't have to be a car tire. This could be a bicycle tire. It could be any type of rubber tire that there. So if your hand is in there, it's going to, you know, it's going to see 400 kilograms per square centimeter type pressure. I mean, it's a lot of pressure right there. So if your hand is in the press, your hand disappears. And I am very intimate with anti-tie down devices because I've seen people lose hands. In effect, I used to work in a company that made clutch facings and gears and things like that, and tires, and we had this type of equipment in that there. And I've seen people that actually did, telling me that I need to hurry up here. Right there. So, right there. So, what an anti-tie down device is, in order to close this press, I have to hit two buttons simultaneously. And we would have operators that were lazy and they would tie one of them down where they could reach in there, grab the tire and replace it, put the new tire in, hit one button while they're pushing it back in. And in the process, possibly losing their hand right there. So you have to design a circuit that prevents that from happening right there. And that's called an anti-tie down device, right, the circuit right there. We didn't cover how you do it. It's actually a fairly complex circuit, but it is part of PLC design that when you deal with industrial automation, you have to put in safety features. So it's a safety feature right there. All right, again, we're running out of time as we got there. This particular explain the operation here. We have a push button right there that turns on this motor. We have another motor here that has to be off before we can turn that motor on right there. And this actually keeps this motor running that there. So the main thing is this right here is actually this motor here. So only one motor can be running at a time. It's essentially the whole idea of this circuit right there. So This starts our other motor, but again, this looks to make sure this motor is not running right here, right there. It turns on this motor. Yeah, this is an output right there. This just keeps it running right there. So, and this last one here is our stop right here. Motor. Oh, this is just our output, just showing our LED right there. So, again, the main thing on this particular one is that we're looking to only run one motor at a time, right there. And that leads itself to problem 3, which I'm not going to go through because, or 5, but problem 5 actually uses, I'll post the solution to 5, right there. And this, by the way, explains the anti-tie down device that's in the solution, right there, and leaves that there, and this is the solution that there. This is the wrongs problem right here, that there. So this is one on a, if you read the problem here, question 5, right there. Question 5.3. This is a okay. B is design the PLC of a heating oven. The oven is heated by an electrical heater. The ventilation is to cool right there, and this happens to be right here. And again, keep in mind that the cooling fan has to run for some time after that there. So this is actually the one on a heating an oven. So it's a different answer right there. I'm going to leave 5B open, let you think about that one. There will be one like 5B. It's actually the one I think is closer to the one on the practice test than the heating oven, but it's right there. So if I do not post this solution by this afternoon, please email me that there. Obviously, I'm going straight from here to the invigilation, so I can't do it right now. I'm just going to go and throw this in lock this in my desk upstairs, and then go and invigilate a final, and then afterwards I'll come back and try to get this posted right there. So that's it. Unfortunately, right there. Yeah, this is the one that's on the final right there. So, okay. With that said,